All right, 2b here. We are doing the limit as x goes to infinity of 5x times the sine of 8 over x. So this is going to be a Hopital's rule problem. I got to do some algebraic manipulation first. This typically falls into like the BC content, not the AB content. So what I want you to see first is that this is an indeterminate form. This is going to wind up going to 0, which is going to make me take the sine of 0, which is going to go to 0. Because when I plug in, well, I can't plug it in, but when I look at the limit as x goes to infinity of 8 over infinity, I get 8 over a giant number, which is what goes to 0. That makes me take the sine of 0, which is also 0. And then I get 5 times infinity, which gives me infinity. So what I have is, which gives me an infinitely large number, 0 times infinity. And remember, 0 times infinity is one of our indeterminate forms from BC. Is it an infinitely large number? Is it 0? Is it somewhere in between? That's what we got to figure out. So what I need to do is do some algebraic sort of twisting of this thing. This is the limit as x goes to infinity of, I'm going to write a fraction bar. I'm going to leave the sine of 8 over x in the top. I'm also going to leave the 5 in the top. And then I'm going to take this x right here and do a 1 over 1 over operation on it. I'm going to put it in the bottom of the fraction and then do 1 over it. I'll just write that like that. I've gone into more detail on why we can do that in other videos and in class and stuff like that, but I get 1 over x in the bottom. Notice if I were to copy dot flip this whole thing right here, I would wind up getting this whole thing right here back. So they're equivalent. Why do I do this? Well, we can use Hopital's rule when something goes to 0 over 0 or infinity over infinity. And if you take a look at this thing, I have the sine. I wind up getting the sine of 0, just like I explained in this previous part. This winds up going to 0. And then 1 over infinity also goes to 0. So what's this fraction wind up going to? It goes to 0 over 0. So it is hoppable. One thing that I want to say is that you want to leave this 5, if we have a coefficient like this, up top. Otherwise, it gets pretty algebraically messy, and it's not worth trying to navigate that algebra. So we're going to leave it up top. Now we said it's hoppable, so I'm going to go ahead and hop it. That gives me the limit that's equal to the limit as x goes to infinity of, I'm going to do the bottom first. That is x to the negative 1. The derivative of x to the negative 1 is negative 1 over x squared. You should be able to do that power rule. And now this one right here. I get my 5, it comes along for the ride, times the derivative of the innards. Well, 8 over x derives the same as 1 over x does. So I wind up getting negative 8 over x squared times, and then the sine of goes to a cosine of, and what goes on the inside? The 8 over x. So what I want you to see is that lots of things cancel here. The negatives cancel to give me a positive, and then the x squareds cancel. So I'll write out the next line. That gives me 5 times 8 times cosine of, just put that negative, so, no, oh, sorry, there's no negative. Times cosine of 8 over x, all over 1. And I guess I need to make sure I carry my limit notation, as you should as well. So x goes to infinity. And look, I don't even really have a fraction anymore, because anything divided by 1 is just itself. So this is just, I can take 5 times 8, that's 40. See, I forgot my limit notation again. So that is the limit as x goes to infinity of, I wind up getting 40 times the cosine of 8 over x. And now, look, this is pretty easily evaluatable, because this gives me 8 over infinity, which goes to 0. So this is 40 times the cosine of 0. And now I dropped my limit notation, but it's fine here because I no longer have x's, and I've sort of like evaluated the limit part of it. And you should know that the cosine of 0 is 1. So that gives me 40 times 1, which is 40. Good job. See ya.